Hello, everybody, and welcome to this session on how to migrate an existing application to serverless. My name is Marcia Villalba, and I want to start with a story. If my clicker works, there. So, the story is my first encounter with serverless. It was around 5 years ago, and I was working in this company where we were doing a service similar to Netflix, but for cartoons. The difference with Netflix is that they have a subscription model, and we were monetizing with advertisement. That project was existing already for many years, and by that time we had 6 billion views. So kids love their cartoons, and they binge on them like crazy. So costs were very important for us. It was beginning of summer, and we got a call from the boss telling us that our service was too expensive. That was the dreaded call. We're always afraid of that call because if our service was too expensive to operate, that means that they will shut it up. But the boss said that we had some chances to make it through if we re-architect our application, if we find a solution. We were free backend developers in that project, and this application was cloud native, so it was born in the cloud and was designed with the microservice idea in mind. By the time of the life of the application, it turned to be free mini monolith, because every time we were adding something, we were too lazy to create a new microservice. I think it happens when you don't have a good automated way of creating microservices, that you keep on adding things in existing services because it's easier. So we have this free little monolith in the cloud. We were free backend developers, very Java experience, but very native, like beginner's cloud. We didn't know anything about cloud economics, on how the cloud works. We have some basics. We could start an instance and do basic things, but we didn't understand the first 6 things. So we started thinking, okay, our application is expensive, so let's make changes that we knew can help the project. But we focus on the code changes. So we make the code more performant, we add caches in our application. We did a lot of things, but nothing that helped. Later, we got an email from the boss saying that this was still expensive. No matter what we did, didn't help. And we were like super worried. So we asked her to please give us a breakdown of all the costs so we can start analyzing what the expensive means, because sometimes you just start doing things without really having all the information. Actually, we were so surprised that it took us a long time to get that report back, because it was not that easy information to access the cost of an application. It was very distributed in many different places, but finally we got it. And by looking at the report, we find that the cost of our application were 2 big problems. The first one was that we were really not thinking about how the cloud worked. We were doing like sending a lot of data from the data centers to our customers. So if you don't know, in the cloud, you are charged for all the data that you take out from the cloud. So you have to be very cautious and take a lot of precautions when you are pulling data from your data centers or regions or availability zones, whatever is called in your cloud of choice, to your customers. So for that, there is many solutions that you can reduce the cost and the latency, but we were not putting anything in place. We were sending our videos, our images, our even metadata, everything was coming directly from our servers. And the second problem is that we were using a lot of services that were created by our company many years ago. So this company was born in the cloud, but in the very beginnings of the cloud, when the cloud didn't have almost any managed services. It only had like the foundational services. So with time, inside the company, we started building a lot of services that we were using, like authentication, our own databases, NoSQL databases, configuration services, queues, whatever you can imagine, we build them in-house. But with time, other projects migrate out from the in-house services to something managed by the cloud or by third parties. But we were so little amount of people, we never migrate out. So a lot of the internal services were just up for us. So we realized that we needed to do a big re-architecture in our application. During that summer, I was playing with Lambda. Lambda was coming out maybe like 6 months ago, and I was just deploying Lambda and playing with the serverless framework and doing like little things here and there. And I was so excited of what serverless had to promise. So I went to my manager and said, let's do the architecture, like re-architecture, everything in serverless. And my manager was so overwhelmed that he said, well, whatever, do whatever you want. And that's our start in the journey of serverless. So I want to take you in this talk in our migration story. It was not the most successful one. I will also take you in other more successful stories for migration. This has been 5 years already, so a lot of water has gone under the bridge. A lot of things have changed, but I think I have learned a lot, not only from my experience of migrating serverless applications, but from hearing so many customers and really discussing these things out loud. First, I want to introduce myself. I said I'm Marcia. I work for AWS as a developer advocate. I'm joined the company like 7 months ago, so it's not something I've been doing forever, but I've been coding forever. So that's something I can tell you I've been doing forever. I also have a YouTube channel where I post videos on serverless and cloud computing. There's over 200 videos on these topics with tutorials, very hands-on. So if you want to learn, I recommend you to go to this link and check it out. This is not going to be a very hands-on talk, but if you want tutorials on how to get started, that's your place. So I want to start this talk with a definition of serverless. I imagine a lot of you already have an idea what serverless is, but I think it's good that we are all in the same page. So serverless is a methodology for planning, building, and deploying software in a way that maximizes value by minimizing undifferentiated heavy lifting. This was said by Jeremy Daly, that is one of the AWS serverless heroes. He's an influencer in the area of serverless. If you don't know him and you're interested in serverless, he's a great guy to follow. He has a newsletter and a podcast with a lot of information out on serverless. But basically what he says here is that the mindset of not reinventing the wheel. We want to bring the most value to our stakeholders, and that's what is all serverless about. Also, Jared Short, another influencer in the serverless world, said that when you're thinking of serverless, you have to think on this way. The first, if the platform has it, use it. If the market has it, buy it. If you can reconsider your requirements, do it to adapt to whatever is in the platform or in the market. Sometimes there is applications that covers 80% of your functionalities, and that's like the most important part of your functionalities, and you can live with that without that 20%. You don't need it. So thinking about the requirements help a lot. And then if you have to build it, own it, have good practices of coding, and take it to the end with the best quality that you can. So let's do a little bit more like concrete example on serverless, because, well, it's a methodology, it's very broad. So I want to talk a little bit what it means to a component, a service, something to be serverless. Basically, it has to adhere to these 4 criteria. The first one is that it scales automatically, meaning that you don't need to worry about scaling. You can just put your website in a serverless components, different serverless components, go to sleep, and your marketing team can make it viral in Korea while you're sleeping, and you know it will handle it. Sure, they're not all unicorns and rainbows. There is limits. There is always these limits that you need to know, but a lot of them are soft limits that you can increase by just calling support. Others are hard limits if you're really using a lot of these services, but in general, it's quite flexible. The second criteria is you pay for your use. This is something that comes from the cloud world. The cloud, like since the cloud has been out, we have been used to this concept that you pay as you use. It's like utilities, you pay your electricity or your water or your AWS bill. It's another utility in your everyday. You use it and you pay at the end of the month. The next one is no managing of infrastructure, and here is a little bit different from the cloud because a lot of the cloud offering is about the virtual infrastructure where we get servers with CPUs and memories and hard drives, and we need to know how many requests and inputs and outputs and so much things that when we are working with serverless, we don't need to know. I think the most kind of servery thing that you need to do when you're working with Lambda, for example, I will talk about Lambda in a second, that is the functions as service offering from AWS, is to decide how much memory you want to give. And that's very linked to performance, but that's the only kind of infrastructure idea that you have to have. But you don't need to worry about it. It's totally abstracted for you. There are servers in serverless as there are wires in wireless, but you don't have to worry about them. They are abstracted there. And finally, the high availability built in. And I think this is something super important as well. In the cloud, you might not have that by default. For example, if you're working with instances, you will need to decide in which availability zone you're deploying that instance. But when you're working with serverless, the service will work in the region, and you don't need to worry about if one availability zone goes down for any reason, then it will just, the other availability zone will take over and everything should be fine. So those are the 4 criteria for something to be serverless. Serverless comes in 2 flavors, what we call functions as a service and then backend as a service. Functions as a service is things like Lambda, Cloud Functions, Azure Functions, and things like that. A lot of them, most of the cloud has an offering, and also there is some open source offerings. Lambda was like the first one to came big. It came like 5.5 years ago on reInvent, and it's kind of disrupted the whole ecosystem, and the name serverless started out of this disruption. I don't know if it's a good or bad name. If you go inside the serverless community, there is so much debate on the name. We software people, we hate naming things. And I think this was named by marketing, but well, that's another discussion. But I want to use the definition of Lambda to define functions as a service. I think it's a good definition to look at. This is what is in the web page. And it says AWS Lambda lets you run code without provisioning or managing servers. Just upload your code, and Lambda takes care of everything required to run and scale your code with high availability. This 2 paragraph is basically what we just saw in the criteria. The difference is that is functions as a service, and the difference between a traditional application that is running in a server is that you can trigger that function from somewhere else. So basically how it works, you type your function, you deploy it in the AWS Lambda platform, for example. It works more or less the same in all the cloud providers. And then your function is idle, is not executing until something triggers. And what can trigger that function? Well, many things can trigger that function. It can be a change in the data state, a record in a database changed, an object was added in your storage, a message in a queue. Whatever you imagine in the state can trigger the function. Also, a new request, HTTP request, and things like that. Also changes in the states, in your application state, somebody click on a button, somebody did something, can trigger the Lambda. Lambda functions come in whatever languages you can imagine. The most popular runtimes are supported by AWS out of the box. If you have some runtime that is not supported, you can always bring your own with our support for custom runtimes. And then this function starts executing, and what you can do with it, basically anything that you can do with a normal application. The limitation is that it will run for 15 minutes. That's kind of the biggest limitation compared to a traditional application, but you can call other AWS services with no problem. You can do HTTP request if you want, calling something in the internet. You can do, I don't know, business logic, whatever you imagine, you can do it there. And then we have the other part that is the managed services of the backends as a service. And these are the services that will help you to not reinvent the wheel. So you need a database, a NoSQL database, key value pair, use Dynamo. You need object storage, use S3. You need a queue, use SQS. There is not only from AWS, you need an authentication service. For example, you can use Auth0, or you need a Mongo database, you can use MongoDB Atlas. There is so many outside there. And these are like the parts that are not really giving value to you unless you're Mongo or you're Auth0, or making a database per se. But if you're in the business of distributing video that we were, this is, we don't need to build and manage our own databases. It's a waste of time and a waste of human resources. So using these services in our application, these are services that fulfill the 4 criteria for serverless components, and S3, I think, is the best example. S3 is storage. Basically, one of the oldest services from AWS. You just store objects in there. And it's extremely serverless. So we were having serverless components since day one of the cloud. So it scales automatically. Nobody ever thought about how many requests you're getting to your S3. It just works. You don't have to manage infrastructure. S3, who knows where it's stored and how many it has been updated and patched and whatever since it was launched in 2006. You don't have to, you pay as you go. And I think this is kind of an interesting example if we compare it with other storage solutions that we are used to, like iCloud or Drive or Dropbox, that we have to buy like 100 gigabytes. With S3, you just put one file that is 1 mega and you pay for 1 mega, or you put petabytes per day and you pay per petabytes per day. You don't have to commit, you pay for as much as you use. And finally, we have the high availability that S3 has in the region, very high availability. So now we are in the same page, all of us. But if we are thinking about this, what I just told you about serverless is way more that I knew by the time I was working on this project. So I told my manager I wanted to go to serverless, but I basically have deployed 4 Lambdas to the cloud. I didn't know much. And I think these concepts were not that polished by then, that nobody could explain them to me. There was a lot of benefits out there, but they were more like sales pitch benefits. A lot of things have changed since then. So we were standing there with my team, well, my colleagues and my boss, and we were thinking like, okay, we have these problems. We want to use these technologies. We can also use these other technologies. We didn't limit it only to serverless. So let's try to think a little bit. So we were in this part of the migration where we were just thinking. We didn't jump on coding something because it's not the best way to go. So the first uncertainty that we had to handle is the lack of technology knowledge. So we wanted to use serverless, yes. So now what? Who knows about serverless? 5 years ago, there was no YouTube channels, there were no courses, there were no a cloud guru, there was no Linux Academy, things offering serverless. There was nothing like what we are used today. So training for learning serverless, it was hard. So my boss told me, well, we don't have a lot of money, but we can find a consultant that has done some little serverless projects and has a lot of experience with managed services in AWS. And he told that he could come only 4 hours a week. So he could not sit with us the whole week. We need to do the best that we could for those 4 hours a week. So this guy came to our project. He was amazing. He was, I think, one of my first influencers in what it means to do serverless applications and what it means to make good quality distributed systems. And we started our workshops first working like a classroom. He was teaching us in the blackboard, like, yes, this is serverless and this is what you do. And as the months progressed, it changed into something that we were doing mob programming. We were all coding together into very interesting discussions where he was learning from our solutions. I think this was a great way to train the team. The 3 of us, all the backend developers in the team, were present in those workshops. We were all learning at the same time. And the cool thing is that all the developers in our team has very different strengths. I was very focused on the full stack development with the client work. My friend knew really well the business and all the business logic, all the crazy algorithms. And my other friend was all into DevOps and how to deploy this and distribute this application. And together, when we start learning all these things, we took different bits and pieces and we make it work in a really well. And I think this is a good learning from whenever you're going to do a migration, that everybody in the team should get involved early on. The education should be very democratized early on, so everybody can feel that they are welcome in the migration and they can commit to it. And the next part, our uncertainty that we had is this, whatever we were thinking, serverless will solve our problem. We didn't know. We have this great, crazy idea that serverless was amazing, the marketing brochure looks great, but will it really work? So what we did is we have these two problems and we start looking at them in more detail. Okay, we want to transfer the video and we want to transfer the metadata. We want to transfer, we want to replace our authentication. We want to replace our database. We want to replace our queues. And we start looking at all the different things that we needed to do. And then we start writing hypotheses on how these serverless solutions could help us. So, okay, we want to replace our existing React tables using DynamoDB. Is that a hypothesis? And then we wrote a minimal buyer product trying to solve that problem. And the cool thing of doing these exercises, by the end of this exercise, we had like 9 minimal buyer products that we keep on improving all the time, and then we find something that worked. And the cool thing is that we learned so much real practice serverless things that by just writing these MVPs with no kind of pressure of having to deploy this code to production, it was a great way to see the real problems solved in this new way of thinking, and it helped us a lot. So now we are ready. We know that this technology can help us. We have our hypothesis. We know where to focus. We know what are the problems that we need to solve. So the next step is to work on our foundational work. In our migration, I have to be honest, we didn't thought about this foundational work as a thing. We didn't have many options when we were doing our migration. The amount of tools and things around for serverless were very limited. But I think nowadays there is so much variety of things that you can take and decisions that you can do that this step is very crucial. So the first thing you have to have in mind is the Conway law. The Conway law states that any organization that designs a system will inevitably produce a design whose structure is a copy of the organization communication structure. Maybe we are familiar with this thing, but basically, if you have one big team, you will make a nice monolith, divide everybody in teams, and you might have a microservice. And that's basically the reverse Conway maneuver and structure your organization to match the software you would like to build. And this is something when I thought in retrospective when I was making these slides that we did in our small team of 3 developers really naturally. Everybody took on many different microservices that we wanted to build, and we took the leadership, and we were we took 2 or 3 each, and all of us have different microservices, so we could not be lazy and put everything in one. So it kind of worked, but in bigger teams, you might need to do bigger structures. And if you're working in the Amazon way, you have to do these 2 pizza teams that are big as you can fit with 2 American pizzas. So if you have a lot of hungry developers, it will be a very small team. If your developers eat less, you can go up further, but it's around 10, 7, 12, 15, I don't know, somewhere there, small teams where the communication flows fast and you don't have a lot of overload. And after you have decided on your team structure, now you have to pick your tools. And here you have to pick your programming languages, your deployment frameworks, your developer tools. We pick Node.js and Serverless framework. We didn't have many options. Our original project was in Java, but Java support by that time was not really good for serverless, so we had to move to JavaScript. There was support for Python, but most of the libraries were still in Node, so that's how we choose our language. But nowadays, you have so many options, and you can even choose in one project to have one language, and the other has another one. That's up to your team, but do an educated decision and not just let the project manager decide whatever they want because they like that language. And the same for deployment frameworks. Some frameworks was best for some particular use cases and others were best for others. So choose the right one for the exact project and that will make your life easier. Another important thing that you need to start thinking of is infrastructure as code. And this is something that you have to think of day one. We're so lucky that this person that came to help us was a freaking fanatic of infrastructure as code. And you only learned serverless through writing CloudFormation. It might sound horrible, but I think that's the best way to learn something, to do it the right way the first time, because you cannot write production code from the console, at least not for serverless applications. You will have to write millions of functions and all kind of resources. So you have to think about it as infrastructure as code. It will minimize your risk and bugs, and you will be able to deploy this same infrastructure in multiple environments. It makes your life so much easier. For example, we had a CI/CD pipeline with 3 different environments that was in 3 different AWS accounts, and we were just deploying the same infrastructure with just different variables, environmental variables to each of the accounts, and it was great. We didn't need to stress about it. So, and also if you follow this path, then your code and your infrastructure can be very close together. I like, this is a personal thing and everybody might have a different opinion, but I like to put my infrastructure in the same project, in the same GitHub project as my code, and then everything lives together. So when I deploy my functions, they deployed my infrastructure, they deploy the code in the functions, everything comes together, and it makes my life so much easier. Another thing you have to have from day one is a CI/CD pipeline. This is something you can use if you are migrating, then you might have already one in place. And nowadays, a lot of them support serverless components. So you just need to check if it supports the things that you want. Others might not, but then inside everybody, in every cloud provider, you will find tools to help you to do CI/CD. So that's super important to create an automated pipeline for day one. And try to be as automated as possible so you can see your code the last time you do the git commit to whatever branch, and then the rest goes automatically and you don't see it until it goes to production. It makes your workflow so much more efficient than if you have a lot of manual steps in the middle. And the last thing, and this is something we didn't do, and I'm just like, every time I think about this, how we didn't do it, I think we didn't do it because there was no tools around. Is the monitoring and observability. Nowadays, there's so many tools for doing monitoring and observability. There is tools internals to the different cloud providers that will give you something. There is a lot of external tools. There is a lot of tools that you're already using in your existing non-serverless projects that have support for serverless components. So it's not an excuse not to have a good monitoring and observability setup. And this is critical because your application is extremely distributed. It's very hard to debug. It's very hard to know what is happening. It's like herding cats. So if you don't have a good monitoring observability system in place where you can enable tracing and you can start seeing the traces flow inside your distributed application, and you can start getting familiar on how to explore and debug these applications on the monitoring tool, then the day that you're going to production, you're going to suffer a lot. And we did because we didn't have this in place. Good, now we are ready to migrate. Until this point, we have not done anything but a lot of homework. So it's good to get to the point of the migration strategies. I will present you 3. The first one is crap, is the one we did. The second one is crap, but it's useful sometimes. And the third one is the one that we are going to focus. So let's start with the first one. The first one is the strategy number 1, is the big rewrite. And the only reason I'm presenting this is because we did it. I don't know why we did it. I think because we were naive, we were afraid of deploying something to the cloud, and also because there were not a lot of tools that allow us to have a mixed system in place. Nowadays there is. So, but because of many reasons, we end up going this road. And this road was a painful road. It was very happy, joy at the beginning. We started, no pressure. Yeah, let's go. Chiki. Months passes and nothing has gone to production. You have not tested your foundational work. You don't know if what you're doing is really solving anything. And then 7, 8, 9 months down the road, the production day comes, and it's the longest week, month, year of your life, depending on how long it takes you to migrate. You will cry, you will suffer, you will notice all the bugs that you have done 7 months ago when you coded this thing that doesn't make any sense right now. You will realize all the things that you've forgotten in your foundational work. You will be tired and demotivated, and no, don't go this way. Unless you're writing a very small project, but if you have a big project, don't. The second strategy is the monolith function. And this is something I don't recommend, but there is many examples of the monolith function working today in production. What it means is that you have one big fat function. You grab your existing application and you put it inside a Lambda function. If your Lambda function is not big enough because you have a very big application, you can use containers, serverless containers like Fargates, for example, or other offerings. And this is only good, I will say, if you have your application on-prem or in another cloud provider and you want to bring it to the cloud that you want to do the migration to. Because to do step number 3, you need to have the code in the cloud already. So that's the only reason why I would say that this is like step 0 in my next strategy that I'm going to talk. If you want to do this, there is some tools here that will help you, tools for Node.js, tools for Java, and if you're using some other languages, I'm pretty sure you can find tools as well for them. So now let's move to strategy number 3, that is the one that I want to spend the other half of my presentation talking, that is the strangler pattern. Meaning that you have a monolith and you start taking pieces out of it like services until you have a very tiny monolith or you have no monolith at all. Not only means that you take off services, it means that you break the APIs and you break the database. So it's quite a dramatic break, but it's going in steps. So now I want to give you 5 steps to migrate a service out of this monolith. For that, I want to start with kind of example application that I might use like 3 times, so it's not something that you need to pay a lot of attention, but this is like typical inventory manager application, a big monolith, or not that big, but kind of hosted in the cloud with 3 layers, authentication, the inventory manager, customer manager, orders manager, business logic in the middle, and then a layer for accessing the database. And then we have a NoSQL database. And the first step that we need to do is find the seams in the code, the bounded context, the packages, the modules, and things like that. So this is something that is super important to do when you have a monolith, tidy it up. The thing here is that there is many ways to tidy up a monolith. You might have already a very tidy monolith written in packages or modules in Java or JavaScript or whatever language you like, but I think here is very strategic to think how big your microservices you want them to be. I like one quote from Sam Newman. He was speaking before me in another room. He said that microservices should be rewritten in 2 weeks. And since I heard that some years ago, I really like that idea. I've been working with my microservices to be that big. So then here, when you're finding the bounded context in your code, you want them to be as big as you can rewrite in 2 weeks. So this will make your strangler pattern very agile and very fast. So this is something to have in mind when you're making these packages, those modules, that they are small to be rewritten in 2 weeks. So your application will look something like this: orders, customers, items, blah, 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 blah. Nothing much. No, still a nice monolith. So now we have a tidy monolith and we need to break the database layer, and now we need to organize the data. Here we will need to make some architectural decisions because we need to break that repository layer into small bits, one for each of the microservices that we have decided in the step before. So we might end up with a lot of repository packages. And here, the first architectural decision that you will need to do is to give owners to each of the tables. And that sounds quite crazy because in some points you might need to decide who owns what table, and you might want to replicate the data because it doesn't make sense to have very complex calls and queries into one service or another, so it's easier just to replicate it. Because now we cannot do joins of tables that are not in the same package. And this sounds stupid or confusing, but it's important for making our migration easier in the next steps. So here we also have to have in mind that we might need to do 2 trips to the database to get a query fulfilled. So if we want to get, for example, all the customer orders with the detail, we first might need to go to the customers, get all the order IDs for that particular customer, and then we need to go to the order service and get all the order details for each of those orders IDs that we got from the previous query, and then we can join them together. So this is something that you will need to do, but it will help you a lot in your next steps. So now we have a tidy monolith and it's kind of ready for the migration. The next step is to choose what you want to migrate first. And then we will rebuild that bit that you decide into a serverless component, and you will end up with something that looks very nice like this. So where to start? Strategy 1, start with the least important part of your system. That sounds nice, get some experience. And then you get some experience and you're still migrating the less part of your system, things start changing and you're like, oh my God, no, maybe not the right one. So this is true, start with the part of the system that has the highest return of the invested time. Start with the hard problems. That sounds nice, but maybe you want to test your foundational work and get some experience. So my suggestion is start with the least critical part of your system, do 2, 3, 4, 5 iterations, services out, test your foundational work, get experience, get motivated, get pumped up, try it and play and improve and rewrite your foundational work and iterate and make it better until you're ready to mow the most critical part of your application. And then you have a plan and you're ready to go. So now I cannot tell you how to re-architect all your applications into serverless because that will take me forever. And I don't know, every application is unique. So I can tell you some things that you can think when you're moving to serverless to have in mind that you can just take in account to get started. So the first thing, and this is something I like particularly, and my experience on building serverless applications is to have logical microservices. So you will have a lot of Lambda functions that are doing things. And those Lambda functions, you have many options to handle them. I like to handle them in the idea of a logical microservice. All these Lambda functions will belong together that do something, for example, handle orders or handle payments, or you can go smaller, it doesn't matter. The important thing is that all these functions work together. They can talk to one particular data store. Nobody outside from these Lambda functions can talk to this particular data store. So the data store is private to these functions. So it's like a microservices. So everybody that wants to get to this data store from outside need to make a call through a Lambda function to the data store. And then this logical microservice is independently deployed from other logical microservices. So you don't have to think about what is the order or what breaks what. Nothing breaks what. And maybe inside your logical microservice, you have Lambdas that are depending on the other, so you cannot deploy them independently. So that's something that can happen, and I think it's quite easy to handle. So this is something I like to do. I like to have my logical microservices as one repo, for example, one GitHub repo, put the infrastructure of these logical microservices, all these Lambdas, and whatever connectors there is inside this microservice, messaging tools, and whatever managed services, and also the database as well, I can put in there. And then everything is deployed all together in their own CI/CD pipeline. I like to do it like that, but that's one of the ways to do it. There's many others, but this is something that has worked for me very well in all the serverless projects I have worked. One concept that I think is important here is that these logical microservices can be rewritten in 2 weeks. And this ties very nicely to the idea of the evolutionary architecture, that you have very decoupled microservices that can be replaced and they can change and you can experiment and try things out. For example, we go back to our story. We were coding this solution for sending metadata to our customers. We wrote the whole solution, all the code. Then November came, reInvent happened, and step functions were launched. A step function is a system that will help you to orchestrate multiple Lambda functions. I will talk about that in a moment. But basically, we have to throw part of our microservice to the trash and just use step functions. We were able to improve our application by just adding a managed service. So that's something, it will happen a lot when you're working with serverless applications, that the cloud or third-party services will start launching services that solve problems that you have written that are not part of your value offering, that you can just replace with those offerings. And the evolutionary architecture is a good concept to have in mind of how your services are very decoupled and modular, so you can replace them, like Lego. Another thing to have in mind is that the Lambdas have to be small, simple, and do one thing. Simple Lambdas are secure. You have to give less permissions to them. They perform way better. They're faster to deploy. They have smaller cold starts, so that's what we want. And you know what they are doing, and you can test them very fast. So when we have all these Lambdas doing one thing only, we need to organize them in some way. There is many ways to organize functions or to organize distributed systems. I will be talking about two different patterns, but you will find more. The most popular is the orchestration pattern and the choreography pattern. The orchestration pattern basically is like orchestra manager that will tell everybody what to do. It knows the states of everybody and it makes all the services work together. Unlike this example, for example, each box is an individual function. It does one thing and one thing only. And then we have this orchestrator that I have not drawn it, but you imagine like a puppeteer that will get the inputs and the outputs and will handle, for example, that in the middle, the get order details that will go to the order service and get one order details in parallel as many times as we have orders, and that with an orchestrator service will help us. We don't need to handle the parallelization and handle when all the functions finish to make the results into one place. If we have a service that takes care of that, it makes your life so much easier. So that's one pattern. Then we have the choreography pattern that is more aligned to what event-driven architectures is. Basically, we have all these functions that are waking up to events that are coming. One events an event, I'm ready, a client has I don't know, been added, and then somebody has to act on that and react. And here, one way to do it is that functions react to events that other functions emit. But that's something that we don't want. We don't want our components to talk to each other. That adds a lot of coupling and a lot of mess to our application. So we need some kind of router to avoid this mess of producers of events and consumers of events. And it makes our code cleaner and decoupler from each other. So if we change Lambda A, then Lambda B doesn't get affected. We just need to change that, and that's it. If you're working in the cloud, you will find a lot of these managed services already in place for providing routers. You have routers one-to-one, like a queue. You put a message to one function and you get it in the other one with a queue in the middle. It will handle buffering and it will handle the load of the functions. It will do a lot of work for you. You can have PubSub. One function emits an event and then multiple different services will get an event. Or then you can have something like an event bus. Somebody put an event and then depending on some kind of rules, the other ones receive the events. All these are part of an orchestration pattern and they are good event-driven components. They will help you to make your software scale easier because these components will add a lot of resilience and they will help you to maintain. If you want to change one part of your application, you might not need to change the rest of your application. And everything becomes very distributed and asynchronous, and that's a thing we want in our distributed systems. Another thing to think when we are thinking about replacing serverless, migrating to serverless components, is to replace existing functionality with whole managed services. For example, we have an authentication layer that manages users and roles and things like that. We can replace that with Auth0 or Cognito, and then we don't need even to code that out. So that's something that is in place, as well as replacing whole kind of things with multiple services. For example, it's quite normal to have analytics pipelines. So instead of coding every part of it ourselves, we can just replace it, the whole thing, with managed services like Lego parts, and we just glue them together. So when this comes, this means that you need to be very knowledgeable of the cloud that you're choosing. When you're moving to serverless, sure, it's very easy to get started on writing Lambda functions, but the learning curve is very steep when you want to start. You need to know so many managed services to make the decisions. So that's something, if you're planning to move to serverless, I recommend you that you not only educate yourself on the Lambda functions, but you also educate yourself on what available managed services are there, because they will help you so much in your journey to start adopting serverless. Then we move to the next step, the step 4, breaking the database. And this is a quite simple step. We need just to get those tables out and put them in their own database. But here is a good way to start thinking if that SQL database, for example, that we are migrating, it's a good solution. Are we keeping SQL? We want to move to NoSQL, we want to move to files. Think how your data is stored. This is a step for that. And the last step is breaking your API. Here we need to break the API that is compatible after the migration with our clients. We don't want to change the clients after our migration. And also, one thing that is available now, and we want, because it makes your life so much easier, is to use traffic shifting to your new service in a way that is gradual. So for example, there is load balancers that you can put in front of your new service that will tell you, okay, you can use now 30% of the traffic goes to the new service and 70% to the old service. And in this way, you can test your new service and not really affect all your users. You can move 5%, 1%, I don't know, depending on the load that you have in your application. So in this way, it makes your migration life way easier. So now I want to wrap this up, because when we finished migrating, it took us around 11 months to migrate. It was very painful. And at the end of the day, our project got still canceled. So I want to talk about a more successful case study. That is the case of Comic Relief. Comic Relief, if you don't know, is like a UK-based company that what they do is they take over TV one day with different musicians and humorists and people from the very popular people in UK. If you ever fly with British Airways, you might have seen the ad that they have for security. Is about Comic Relief actors. I don't know anybody, but if you're British, maybe you know. And these guys, what they do, they collect donations during that day, and they have this peak of donations of 350 donations per second. Maybe it doesn't sound very big in your head, but remember, donations cannot get lost. If you lose a donation, that means that money that is not arriving to some child that might need food or healthcare. So you don't want to lose any donation. If somebody donates money, they might not donate it again if you lose that transaction. So every donation is important. You cannot have duplicated donations. You donate once, you want to collect all donations in one time. So the scaling becomes a problem. So in 2016, this was their architecture. Basically, they started the migration process more or less in the same time that we started our migration process. They have a Drupal monolith and some things there that was for their web page and whatever. And the most important service is the donate service. That's the one you need to focus on, because that's the one that needs to handle the donations and needs to be very resilient. That's the critical service. That's the most important part of their application. 2017 came and they started doing some changes in their architecture. They migrated to a new version of Drupal, and then somebody in their architecture team, engineering team, decided that maybe they need to do something new. And what they did, they migrate one of the least important services that they have into serverless, React, and all these kind of things, getting out from the Drupal monolith into something more modern and easier to use. So they migrated this fundraise gallery that was just an image gallery to this new technology. They validated that that worked very well, so they picked other services that maybe they were a little bit more important, but not as critical as Donate, to migrate to this new technology. At the same time, they created some kind of architecture and infrastructure that will support the migration and the creation of new services. They extracted things out from their existing services, making them smaller and easier. And in 2019, now they were very confident on their architecture, on whatever they were doing with serverless and React and Node, and now they were ready to migrate that big service, that .NET service. So they did it. They migrated. It took them a while and got the whole thing up. The architecture is here. If you want to check it out, it's in that link. I will not go into the details, but basically this is extremely resilient architecture. Everything has a backup. If something fails somewhere. So all donations are catched and nothing gets missed. And it's a crazy architecture. It's quite simple. It handles a lot of money. So this is quite, at least for me, the first time I saw it, it was very shocking. Their cost of running their service during 2015 was $84,000. One day a year. That's just crazy. By March 2019, the cost of running their service was $5,400. You still think, wow, that's a lot of money for one day. Now they don't run it for one day. They have the availability to donate all year round because their new architecture allows them to do that. And most of that cost goes to something else because to serverless only costs $92. That's the cost of running the whole serverless infrastructure. They have done it with infrastructure as code and good practices, so they can rebuild the whole thing if they need it again tomorrow with no stress. So if you want to donate, you can do it all year round in this link, and you will be helping some kids that need it. So that's always good. And now I will be doing a little bit closing remarks, going through the most important things, that is infrastructure as code, infrastructure as code, and infrastructure as code. Decompose your monolith into little microservices that last for 2 weeks to rewrite. Automate everything. Distributed services are like herding cats. You want to have things that are under control and you can automate so you don't have headaches when you have to know what is the status of things. Asking people is not an option. Automate everything. Use tools that are standardized across your projects. Try to decide on which tools you want and why. And finally, if you want to go through all the steps, do your foundational work, move the monolith to the cloud, find the seams of your code, your bounded context, organize your data layer, move the code to serverless, break the database, break the API, and repeat from 5 to 7 until you're done and you're happy, happy, joy, joy. And that's it. I will take some questions now, and if we don't have time for more questions, then I'm always active on Twitter. I can reply there. My messages are always open for handling questions. So I will open the Slido. Let's see. I don't know. Can you see my screen? Now I'm confused. No. Okay, I hope you can see my screen. So we have 2 questions. The first one is, will you choose Azure Functions over Lambda? I work for AWS, so what I can tell you about. Is a choreography pattern. How do you ensure that Lambda Functions handles the events successfully? No. Lambda will have different mechanisms to handle events. It's important that when you using Lambda, if an event can trigger Lambda multiple times, so it's important that your function is either potent or however you pronounce that in English, meaning that if you apply the same function, you always obtain the same result. The Lambda platform will take care of calling the Lambda to make sure that the function handles the event. Sometimes you don't get that. And for that, you have these dead letter queues that you can attach to your Lambda functions that will collect all the events that has not been handled for some reasons. There were some errors and things like that. So no, choreography is not how you ensure that a Lambda function handles the event. You use the dead letter queue and you use the mechanisms that are coming inside the Lambda platform. Is there any other questions? So if there is no other questions, thank you very much. And I will be hanging out around in the Slack for a while. You can pick me there, or then in Twitter at my Twitter user that is, I don't know. Well, you can find me marcia.dev as well. There you find all my information and everything that you could find me online. I'm always happy to answer any questions and have any discussions. So thank you very much. I think we can wrap up this